Hi there, in this video I'm going to talk about retrieval-augmented generation. I'll show you a use case and a concept, and then we'll jump into some sample code. So one of the very popular use case of retrieval-augmented generation is chat with PDF. And here I have a PDF document which has got the story of one of my favorite films, Matrix. So we are going to upload this into a RAG application and then we are going to chat with it. So here I have my RAG application and let us now upload the PDF. Alright, so the PDF has now been loaded and let us now ask some questions. So let us ask a question such as who is Neo? Now the application is going to check the PDF and retrieve the answer. And here it says that Neo, whose real name is Thomas Anderson, is a computer programmer, becomes a key figure in fight against the machine controlling the humanity. So the answer is perfect. And then here you can also see that what parts of the PDF documents were taken in order to create this answer. So this is a fantastic application of retrieval-augmented generation. And now let me talk about on how it works and also show you some sample code. So here I'm going to show you on how this RAG pipeline works. So first of all, you need to extract the text from the PDF document. So you have the PDF document, you then apply a Python package called as pypdf2, which is going to convert the PDF into raw text. Afterwards, we have to chunk this text into smaller pieces, and this is called as the text chunks. And then once you have created these text chunks, you have to convert it into embeddings, which are this vector representation of the text. So you take these text chunks, you then use any large language model. In this case, I'm using the OpenAI large language model, and you convert it into vectors, or also called as embeddings. And then you need to store these vectors into a vector database. There are various vector databases, and here I'm using a very famous vector database called as ChromaDB. Now, once you have saved the vectors, it is time to ask questions to the PDF document. So you give a question, you convert the question text also into an embedding, and then you try to compare the vector distance calculations. You try to find out that which vectors which are stored in the vector database are closest to the vector of your question. And here it will retrieve the top 5 chunks which match your question, and then we send those text chunks again to a large language model which is going to make the final answer. Now let me give you a quick summary of how the code works. So first of all, this is the piece of code where you are extracting the text from PDF, and here we are using this PDF reader as well as we are using this code to chunk the text. And once you have done that, you can send these text chunks to OpenAI large language model, and here I'm using the package from OpenAI, and here you have to use a large language model called as embedding, and here I'm using text embedding 3 small. And once you have done that, you get all the embeddings which you can then store it in a vector database. So here I'm using this ChromaDB as a vector database, and you can just create a collection and then add all the chunks, all the embeddings which were created into this vector database. Once that is done, you are ready to ask questions, and you convert first of all the question also into a vector embedding, and then you can use this collection.query, which is a functionality provided by ChromaDB. You give your embedding and it is going to search the vector database to find the top 5 embeddings which match your question. And here it uses various distance measures, and one of the most popular distance measure is a cosine similarity, where it will compare the vector of your question to all the vectors using cosine similarity function. Now once you have all the retrieved chunks, you again send it back to a large language model, and which is going to make the final response and generate the answer for you.